Hello Legacy Sabers, Marsh here. So today we're going to talk about the other two shortcuts to similarity, SSS and SAS, what you want to have on you, the little booklets that we made in class, your notes, and then also a calculator that you can simplify fractions with. The first one we're going to look at is SAS Similarity, so go ahead and grab that booklet out so that you can write on it. Go ahead and open it up to the first page. First of all, we need to talk about the definition of SAS similarity. What does it mean to have that, or when can you call SAS similarity? Well, when you can use this is if two sides of one triangle are proportional. You're going to want to write down the examples in this stuff today as well. Sorry I didn't put the pencil in the corner. So if two sides of one triangle are proportional to two sides of the other one, and the angle in the middle, the included angle, is congruent to the other one, then you have two triangles that are similar. So if I look here on this side here, I have an angle congruent, so angle A and angle F are congruent. Now let's make sure that the sides are congruent. So I think that 8 and 12 would be related. So it'd be 8 over 12. I think I can divide both of those by a 4. So I'll get 2 over 3, it looks like. Let's try the other one. 4 over 6. Divide that by 2. Divide that by 2. I'll get 2 over 3. Which means that they are congruent, or they're proportional to one another. They are to the same ratio. So when you have that, that means that they are similar, because I have two sides proportional to one another, an angle in the middle, and then two sides proportional. So let's go ahead and write our similarity statement. So we knew 8 was related to 12, so that must be, or if I put A, B, C, so A, B, C over here, so then triangle, looks like I gotta start in the angle again, so that'd be F. And then 8 and 12 were related, so it'd be F, E, D, it looks like. Like that. Now let's try a couple of examples of SAS. So very first thing I notice, I do have angles congruent, 61 and 61. Notice it's in the middle of two sides, so we just need to check those sides here. So I got 6 over 10, so that would be, looks like divided by 2. So I'll get 3 over 5. Okay, let's check the other one. That one is 3 over 5 right away. So it seems that these two sides are proportional. So BC to EF and AC to DF. So what I can do then is I can say yes, similar, by, and we're using SAS, side, angle, side. Then let's write our similarity statement. So I got triangle BCA, so I went BCA, I got to do the same thing, so EFD looks like. There we go. Let's try the second example. Now this one looks kind of confusing because it's the two triangles in one kind of thing. So I think what I'm going to do is I'm actually going to draw them out on their own. So I got the little triangle here. He would be VWX. He has lengths of 4 and 5 right there. And then let's draw the big triangle guy like that. So I got V, Y, and Z. Notice this full side of V to Y right here. It's not just 8, it's 4 plus 8, which would be 12. And then 5 plus 10, that would be 15. Now you're probably saying, Marsh, they don't have an angle in common. We didn't mark any angles. Well, notice how they both share angle V. Right? They both are technically that same angle, so those two angles are congruent. Thus I have side, angle, side. Now let's check to make sure the sides are proportional. So 4 over 12, divide them both by a 4, so I'll get 1 over 3. Let's do the same thing with 5 over 15. So I'll get 1 over 3 as well there. So that must mean that I have proportional proportional sides as well. So now these two triangles are similar, and they are similar by SAS. So I have triangle, it's little guy, so VWX, they are similar to VYZ. Let's try the third example here. So it looks like I have angles congruent because the 90 and 90 are congruent to one another. Now let's try the sides. Let's make sure the sides are proportional before I can call them congruent. So I got 8 over 6. I think that's both divisible by 2. So that would be 4 over 3. That's as simple as it can go. Let's try then 12 over 8. Divisible by 4, I think. So that would be 3 over 2. Notice, guys, my two ratios, once I simplified them, are not equal. They are not equivalent. The scale factors are not equivalent, which means not similar. We cannot call these guys similar. So just because it looks like it's SAS does not mean it is. You need to check these sides. Make sure the sides are proportional. Otherwise, it's not going to work. Last example for SAS, and then we'll move into side, side, side. So, looks like I got a bow tie here. So one thing I do know is that these are congruent because of vertical angles. So I do have angles congruent. Now I just need to think about the triangles here. Well, 25 and 15. So 25 is the larger side. So I'm guessing 25 goes to 30. And if you kind of can imagine it kind of spinning to interlock, 25 and 30 look like they match. So let's go ahead and check to see if those are proportional, or what's the ratio of them. So that would be 5 over 6. We're going to do the same thing with 15 over 18. Looks like a 3. So that'd be 5 over 6 as well. So notice, guys, my ratios are equal, so that must mean that my triangles are similar. So I can call them similar by SAS. So I'm going to say triangle MDN is similar to, so an MDN. Now, M and D was to F and D, so I think I'm going to have to go this way for my other one. So that's going to be FDE. Alright, so go ahead now and grab out your other booklet, the SAS Similarity booklet. Open it up to the front page here when we have the definition of side similarity. So you're now probably wondering, what does it mean to have side similarity? Well, kind of like when you had side congruence, that all sides were equal. What this is going to be is that all sides are proportional to all sides. Pretty much that's what it's going to be. So you're going to want to check every single side to make sure they're all proportional to the same thing, aka they all simplify down to the same fraction. So over here I got a couple of triangles. I'm going to start on A and go to B each time. So 8 to 4. I think that would be 2 to 1. Then I'm going to go 10 to 5. That's also 2 to 1. Then 12 to 6. Also 2 to 1. So notice, guys, how the ratios or their scale factors are exactly the same, so which tells me that these triangles are similar. So let's go ahead and write our similarity statement. I got PQR. That would be STU. Like that. So let's try a couple of examples here. So all we have to do is check sides over sides, make sure they all simplify down to the same thing. So it looks like these, I do not have to organize them any different. So I got 6 over 9. That would be, I think, 2 over 3. That simplifies down to 2 over 3. I started on B and went to A this time, so I got to do that again. 8 over 12. That'd be 2 over 3 as well. And then it looks like it's 10 over 15, which would be also 2 over 3. So all of my ratios are equal, which means I should be able to say they are similar. And it is by SSS that I can call them similar because I do not have any angles congruent at all. But let's go ahead and write my similarity statement. So I'll have CDE is similar to triangle. So I went bloop, bloop, bloop. I gotta do the same thing. FGH. There we go. Let's try the second example here. So we gotta put sides over sides, it looks like. Don't have to organize them, make them look differently. So I can go 18 over 15. That would be 6 over 5. And then I got 36 over 30. That would be 6 over 5 as well, because I can divide a 6 into both of them. And then we got 24 over 20. Divide a 4 into both of those. That is also 6 over 5. So all sides have the same ratio. So let's go ahead and set up my... first I gotta say they're similar. By SSS. So I know they're similar. So I got MPN is similar to triangle TSR. Third example. Notice, guys, these triangles are not drawn the same way. So either A, I'm going to draw them out differently, or we can just kind of make sure we put sides over correct sides. I can go 8 over 12, right? Because that looks like if I turn this guy, flip him around the GHJ triangle, he'll match that one. So that would be 2 over 3. And then I can go 12 over 18. That would be, divide a 6 into both of those. So that would be 2 over 3 as well. And then it looks like 16 over 24, which can divide a 4 into them, which would be 4 over 6. Oh, that simplifies down to 2 over 3 as well. So it looks like all my ratios are equal, so I can say they are similar. And it is by SSS that they are, because I have all sides equal when I set them in proportional, or they are all proportional. So I got triangle UWV is similar to, like that. So gotta do the same thing over here, it looks like. So that'd be JHG. Fourth example of the video, and the last one. So let's go ahead. You know what? I think I'm going to draw this guy down here so he looks similar to that guy. Otherwise, I think I might get confused. So it looks like it will be S, R, and Q. S and R have 30, S and Q is 15, and this is 25. That way it makes it easier for me to see what sides relate to what side. So I can go 84 over 30. I'm going to divide them both by 2. So that'd be 42 over 15. I know a 3 can go into both of those. So that would be 14 over 5. 5 does not have any other numbers besides 5. So 14 over 5 must be it, as low as that fraction can go. Let's check the other ones. So we got 70 over 25. That'd be 35. Oh, I can't divide them both by 2. That won't work. But I can divide them both by 5, which would be 14 over 5, right? 'Cause 70 divided by 5 is 14. So that one's good. Let's check the other one. So 42 over 15. I know they can both divide by 3, because I did that above there. So that would be 14 over 5 as well. So all sides are similar. That works. So I can say they are similar by SSS. And I know that is triangle VUT, similar to SRQ. And that's the end of this video. See you later, Sabers.